Juso is swimming underwater at a depth of 35 meters. Juso then races towards the surface at a rate of 6 meters per second, eventually to jump out of the water. Write an equation that models Juso's height above the water as a function of time. So, let's start by identifying our important information. So here we know he is at a depth of 35 meters, and also that he is racing towards the surface at a rate of 6 meters per second. Okay. So also it doesn't use words like at least or at most or greater than or equal to or less than or equal to. So I know that this is an equation. So I'm going to write that so I don't forget. So this is going to be an equation, not an inequality. Ooh, I cannot write equation today. Let's just, so it's an equation. Okay. So now I'm going to look at these key features and I'm going to determine whether they are a slope, a y-intercept, a total, or a point in the situation. Okay. So the first thing I'm going to look at is the easier one. I see the word per. So I know that the per means that it is a slope. So I know my slope is 6 meters per second. So m is 6. Okay, remember slope is m. Okay, next what I see, I've got my 35 meters. Okay, so could this be a starting point? Yeah, Juso was starting at a depth of 35 meters. So this could totally be a starting point. It's not a total because it doesn't say that's what that's his total depth, for the whole thing. That just says that he's at 35 meters. And it's definitely not a point in the situation because it doesn't have both an x and a y. So then we know that b is 35 because that's our starting point. And then I just put it in my y equals mx plus b, and I'm good to go. So I'm ready to put it in y equals mx plus b. So y equals mx plus b. So y equals 6x. Ooh. Can I write today? I apologize, you guys. So it's 6x plus 35. Okay, and that's the situation. Ta-da!